So the solution to this equation is trivial, although it took you guys a little while because you're processing everything. You get y equals 5/2 x. Okay? Now you also are on this constraint curve, right? In this case, it's a line. So y equals 5/2 x. You're on the line, 2x plus 5y equals 0. How do you figure out the coordinates? Just tell me.
Plug 5, or put 5/2 x into the other equation.
Yeah, you replace y with 5/2 x, right? And it isn't equal to 0, it's equal to 4. It's a good thing it's equal to 4, because if it's equal to 0, it would be the origin. But then our line would have gone through the origin, right? Okay? And that certainly would have been our minimum point. So 5/2, 2x plus 5/2 y equals 4. So 2x plus 25/2 x equals 4. And I don't know if that's even going to be readable, but yeah, high definition YouTube is pretty readable. Okay? And it's a pretty good camera. As long as I'm not down off the screen, I don't think I am. Right? Well, what's that tell us? Well, that's 2x is 4/2 x, so 29/2 x equals 4, right? So x equals 16/29. And you could find the y, right? And I'm not going to work out the arithmetic of that. That's algebra 1. Okay? That's where it's going to be, and that's going to turn out to be a minimum. Okay. Now let's use the method that your book gives you. Okay? This is it. I mean, this reasons it out, right? Now, if I have a curve where the slope changes, things get a little more complicated, because then I have to say, okay, what's the tangent line, and when is the tangent line perpendicular to the gradient? Okay? I could do that, but it's a little more efficient if you use the formula in your book, and then you get a deeper understanding if you visualize the constraint as a level curve of a function. Okay? And you don't know what I mean by that, but you will. Okay? So let me first apply the method, then go back and see why we talk about level curves and two gradients. And it just comes down to this. The test is the gradient of this function parallel to the gradient of this function? That's equivalent to everything we've done, okay? So let me write that down, then we'll write it down in a little more detail, because we've got to understand what the condition is. So now our test, our official mindless test.
Economics, U.S. history, world.
Our official mindless method for doing this, which engineers will love. Yeah, admit it. Okay? You know, I mean, yeah, if you don't absolutely love thinking about it like this, it means you probably don't want to be a mathematician, and being an engineer is a great way to apply your very fine mathematical skills without having to think about all this stuff, right? Even though, again, I keep encouraging you to think deeper so that you can be a deeper engineer, okay? Like if you're into geothermal, you got to go really deep. Think about it. Okay, and don't count on my spontaneous humor as being worth anything. Okay, official mindless method. Find where del G equals del F. where G is a level curve
Yeah.
of a constraint
Wesley, when you just want to figure it out.
function. I'm probably not stating that with exactly the words that I would like to, but that's brief enough, okay? So in this case, where's G? Here's your G, right? So I can't take my hand off this board or it'll fall. But you got that down? So, okay, in this case, F equals x squared plus y squared. G equals 2x plus 5y minus 4, which is the thing we just solved down here. It's not this, okay? Actually, yeah, it's this for the function that I had up here originally with the 2xy in it, right? Okay. So I probably ought to say that. Okay, F equals x squared plus 2xy plus y squared. So we can read the board and see that this applies to that function, but this all now applies to this modified function, right? Okay, so the thing we just solved for this function, just tell me where del G is, and I wrote equal when I meant to write is parallel to, okay? Have to turn my equal sign 90 degrees, rotate it 90 degrees in the positive direction.